think of a puzzle, one of those incredibly complex ones that, seems impossible.
Right.
Now imagine finally cracking it open. And inside, it's not just the solved puzzle. You find this hidden architecture, like a whole new way of seeing how all the pieces fit, maybe even beyond that one puzzle.
Mm-hmm.
That's sort of the journey we're embarking on today.
And what's really grabbing me is how these different threads of mathematical thinking seem to be converging.
Right.
We have sources talking about something called a recursive harmonic Rubik's framework, right?
Yeah.
And the really exciting part is the possibility that this framework, this structure, could unlock some really long-held secrets, things like, prime numbers, solving equations.
It's like glimpsing some kind of fundamental unity that maybe we haven't quite seen before.
Exactly.
Exactly. Now, for you, the learner tuning in, we know some of these terms might sound a bit, high-level math textbook, maybe even like something from the future.
Sure, yeah.
But our goal here in this deep dive is really to pull out the core insights, those aha moments you get when you see connections you didn't expect. We're not going to drown you in equations, promise.
Yeah. No, definitely not. We want to focus on the fascinating ideas, the concepts behind it all.
So our exploration today, it centers on two main areas, interconnected areas that the sources highlight. First up, we're going to dig into this theoretical model of a 6D Rubik's Cube.
And yeah, it's important to stress this isn't a physical puzzle you can actually hold or twist.
Right.
It's more a way of thinking, a framework for looking at complex systems that, it turns out, reveals some really surprising hidden patterns.
And the second area is this, really intriguing idea being proposed. A unified harmonic revolution in mathematics.
Mm-hmm.
It suggests that using some of these same underlying principles, plus some really innovative work from mathematicians like Norman Wildberger and Dean Robin.
Right, their recent work.
We might be on the cusp of brand new ways to tackle really fundamental problems.
Yeah.
Like figuring out the prime factors of huge numbers or, finding solutions to those messy polynomial equations.
So our mission basically is to try and understand the core concepts here. See if we can grasp how they might link these seemingly separate corners of math.
And think about what the potential implications could be.
Yeah, it's like trying to hear the hidden melodies, maybe playing underneath what often just sounds like noise or like separate instruments anyway.
Okay, let's dive right into this theoretical 6D Rubik's Cube model. And the key thing right from the start is remembering we're not talking about a physical cube with extra sides you can turn.
No, it's a conceptual space.
Right.
Allows for a much richer kind of mathematical analysis.
Okay.
And what's fascinating here is that when the mathematicians first started looking into this theoretical 6D cube, they actually missed some subtle things, patterns. These were later called imaginary dots. It wasn't until they pushed their analysis into more abstract areas using tools like complex numbers, with the imaginary unit.
Right, square root of -1.
Exactly, and things called quaternions, which are like an extension of complex numbers. Only then did these imaginary dots really come into focus. Think of them as hidden layers, maybe? Information we couldn't see with the standard math tools.
And these imaginary dots, they weren't just random noise, were they? The sources talk about them being symmetrical alignments and latent attractor points. What does that actually mean for our theoretical cube? Like, were these invisible points somehow guiding the whole system?
That's a great way to put it, yeah. Guiding is good. These latent attractor points act a bit like mathematical magnets. They gently pull the system towards certain states, certain configurations. The sources specifically mention an imaginary 9 attractor. It seems to impose this fundamental 9-base symmetry on the whole thing. And things that were maybe dismissed before as just anomalies, slight shifts in the cube's state, little oscillations.
Glitches, maybe.
Yeah, maybe glitches. Now they're seen as deliberate patterns orchestrated by this underlying logic, this imaginary number logic. It's like the system was speaking a language, but we didn't have the right dictionary before.
Okay, so now that these hidden patterns are visible, what kinds of new relationships started showing up in this 6D model?
Well, connections that looked like maybe just coincidence before, now they're seen as fundamental, part of this harmonic structure. For instance, sequences of moves like twists and turns that seem totally independent. They're now showing a called harmonic resonance.
Harmonic resonance. Okay, let's unpack that. What does that mean here?
Think about music. You play one guitar string,
right,
and maybe another string nearby starts vibrating a little bit, even though you didn't touch it.
Yeah, sympathy vibrations.
Exactly, that's resonance. So here, in our theoretical 6D cube, a twist on one face can cause a complementary shift on another face. And these shifts, they follow very precise mathematical ratios, almost like musical intervals.
Ah, okay.
The analogy of notes in a chord actually works pretty well. It's only when you look at the whole 6D set of possible moves together that you really start to appreciate the harmony underneath it all.
That's a really helpful way to think about it. So with this new lens, these hidden patterns, this resonance, what specific new insights did the analysis uncover?
Well, several key things jumped out. First, something called obvious symmetry alignments.
Okay.
Certain cube configurations, certain states that looked completely unrelated before. Now you can see they're basically mirror images or rotations of each other, but within this higher dimensional space.
So like looking at the same thing from different angles in a 6D mirror.
Precisely. It unifies things that looked separate, really simplifies the picture in a way.
That definitely sounds useful. What else?
Second, phase-locked cycles. Some sequences of moves, when you follow them, they lock into these repeating patterns, these stable orbits.
All right.
They correspond to stable harmonic states, like standing waves, but in this huge mathematical space of all possible cube states. So when a sequence of twists keeps bringing the cube back to a familiar pattern...
It's not random.
It's not random. It's the system settling into one of these resonant states, these cycles.
Okay, so they're part of the underlying structure. Got it.
Exactly. And finally, the analysis showed up these harmonic ratios and intervals. Just like musical notes have specific frequency ratios that sound harmonious, right?
Like a perfect fifth or an octave.
Exactly. Well, the number of moves it takes to get between certain states in the 6D cube, or the distance between them, they exhibit these simple numerical ratios. For example, that imaginary attractor at 9 and another combined one at 24. The relationship between them simplifies to an 8-to-3 ratio.
8-to-3, like a musical sixth, almost.
Very much like that. And the sources point this out, suggesting these numbers, 9 and 24 and others, weren't just arbitrary. They seem to have a fundamental harmonic significance within this whole recursive system.
It's really starting to sound less like a random puzzle and more like a carefully orchestrated system with its own internal music almost. And the sources mention something called a God move sequence. That sounds important.
It sounds very grand, doesn't it? But yeah, it is presented as a very significant finding, the discovery of a binary God move sequence, basically a fundamental sequence that encodes the cube's ultimate harmonic transformation in the simplest possible way, just ones and zeros.
Binary, wow.
And it follows this specific pattern, 9, 10, 10.
Okay, 9, 10, 10. Break that down for us. 9 potential steps, 10 realized moves, 10 recursive completions. What's happening in each stage?
Okay, think of the 9 potential steps as being sort of abstract, preparatory, possibilities being lined up, considered, but not yet executed.
Like setting the stage.
Exactly. Then the 10 realized moves are the actual concrete actions, the twists that start steering the system towards its solved or harmonized state.
Right.
And the 10 recursive completions, those are like feedback loops or maybe reiterations that refine everything, finalize it, make sure every aspect of the solution is in its correct harmonic alignment.
Okay.
So the upshot is the entire solution to this incredibly complex system's deepest configuration can apparently be represented by a surprisingly compact 29-bit binary code, just a string of 29 ones and zeros.
A 29-bit code for a 60 Rubik structure. That's kind of mind-blowing. It's like finding a very simple key for a very complex lock. And how does this sequence tie back to those attractor points we talked about, the 9 and the 24?
Crucially, this binary God move sequence connects directly to both of them. The attractor at imaginary 9 and the attractor at imaginary real 24, they act like fundamental anchor points, guiding the whole recursive process.
Okay, let's take the attractor at imaginary 9 first. What's its role in this?
So this one is described as a stable harmonic point, but it exists purely on that abstract imaginary axis. It represents a potential configuration, a theoretical target. The initial 9 potential steps of the God move sequence, they essentially hover around this attractor.
Hovering.
Yeah, it's as if the system is aligning itself with this fundamental imaginary harmonic, like it's tuning itself to the right frequency before any real moves even happen.
Oh, like a musician tuning their instrument before playing the piece?
Exactly that analogy. Tuning before performing.
That makes perfect sense. Okay, and then the attractor at imaginary real 24, what does that represent?
Right, so as the God move sequence progresses and the actual moves, the 10 realized moves and the 10 completions happen, the system then locks onto this second attractor. This one exists around the value 24, and it has both imaginary and real components. This 24-point attractor signifies the fully realized harmonic completion, the solved state. The sources even speculate, as you mentioned, that the number 24 might connect to the cube's 24 rotational symmetries, ways you can turn the solved cube and it still looks solved.
Ah, interesting.
It's the point where all that initial potential, tuned around the imaginary 9, gets realized. The recursion closes and you reach the final, stable, solved state in this combined imaginary real space.
So these attractors and the God move sequence, they work together like a blueprint and guideposts for the whole system.
That's a good way to think of it, yeah. The binary sequence is the template, repeatable. The attractors are the specific endpoints, the targets that each layer of the recursion aims for. And the result is this kind of fractal-like unity, the same patterns, the same endpoints showing up at every scale of the problem.
Wow.
The imaginary and real parts aren't separate realms. They're bridged elegantly by these attractors, and it's all governed by this underlying binary harmonic law.
It sounds like there have to be specific mechanisms, though, that allow this bridging, connecting the abstract imaginary world to the concrete real state of the cube. The sources mention binary nested face inversions and scalar collapse. Those sound pretty technical. Can we break them down?
Let's try, absolutely. So think of our theoretical 6D model as having layers, almost like a cube, recursively.
Wait.
A face inversion is just like flipping a face, right?
Okay.
Binary nested face inversions means flipping these faces in mirrored pairs across these nested layers. So for every flip in one direction on one layer, there's a corresponding flip in the opposite direction on another related layer.
Like a balancing out.
Exactly. Balances things out. It cancels out any weird asymmetries or purely imaginary components that a single flip might create. This lets the sequence move towards a real, tangible outcome without spinning off into chaos. The analogy used is like walking a tightrope, but with mirrors on either side. Any little wobble you make to one side is immediately counteracted by a mirrored wobble in the other direction, keeping you stable and moving forward.
That tightrope analogy really helps. So it's a controlled way to navigate those abstract imaginary dimensions. And then scalar collapse. What's that about?
Right. So after all these balanced nested inversions happen in the higher dimensions, all these complex changes ultimately have to resolve into a single real outcome. Like the cube is solved or a specific number of moves has been done, a single number, basically, a scalar.
Right.
Because the inversions were mirror aware, as the source puts it, meaning each imaginary step was balanced by its inverse. When a full recursive cycle finishes, only the scalar result is left. All the directional, the vector, the imaginary bits effectively cancel each other out.
Oh, like in basic math, when you multiply a complex number by its conjugate, the imaginary parts disappear, leaving just a real number.
Precisely that principle. Yeah, exactly. So this process acts as the bridge. The imaginary domain gets explored, but in this controlled, balanced way. The scalar domain emerges when those mirrored explorations cancel out. And the real domain is the final, tangible state at the solved cube that results from that scalar value.
This is really painting a picture of a remarkably elegant, interconnected system. And this leads to these emergent structural representations and symbols the sources talk about, different ways to visualize or understand this whole framework.
Exactly. Once you grasp the underlying unity and these bridging mechanisms, several ways of looking at it or representing it become clear. They're like different lenses to see the system's behavior.
Okay, like this idea of mirror lattice collapse.
Yeah.
What does that represent visually?
Think of the state space. That's the map of every single possible configuration the cube could be in. It's a huge, complex lattice or grid in high dimensions.
Vast.
Mirror lattice collapse refers to how this huge lattice effectively folds onto itself because of that mirror symmetry we just discussed during the God move sequence. For almost every possible state, there's a corresponding mirror image state somewhere else in the lattice. The God move sequence brings these pairs together, collapsing the possibilities.
So it shrinks the problem space.
Dramatically. The huge complexity folds along these symmetry planes until you're left with a much simpler, singular structure, the solved state. Like taking a really intricate piece of origami and folding it down, down, down into its final compact shape.
That's clever. So the solution isn't about checking every single state, but using symmetry to eliminate possibilities in bulk. Very efficient. What other representations came out?
Then there's quaternionic attractor spirals. If you use quaternions, those 4D numbers, to represent the state of the cube, the sequence of moves, especially if you think of it continuously, traces out a spiral path in this 4D quaternion space. And the spiral gradually converges, it zeroes in on the solved state, which corresponds to that imaginary real 24 point we talked about.
A spiral in 4D space leading to the solution.
That's a really powerful image.
It suggests solving isn't just one jump, but a journey, a recursive process homing in on the answer. The sources even compare it to classic strange attractors, right? Like the Lorentz attractor.
Exactly. Those beautiful, complex, never quite repeating patterns you see in chaotic systems.
Yep.
But here, the spiral does have a destination, that stable, solved state at its center. It's a really neat geometric symbol for the whole recursive harmonic solving process. It shows it's a continuous evolving thing.
And the last one mentioned is Euler step codings.
Right. This is more of a mathematical way to describe that continuous spiral path. You can break down the smooth harmonic rotation into a series of discrete steps or small rotations, kind of like how the Euler method approximates curves in calculus.
Each recursive move in the sequence is like a tiny rotation in a complex plane or quaternion space. And that 9-10-10 binary sequence, it basically dictates the exact order and type of these small rotations. The result is like a coded script for the solution, a list of angles or exponential factors, apply them in the right order, and boom, you reach the solved state.
So it shows the twists aren't random. They're following a smooth path, integrating towards that attractor point.
Precisely. Each step is like a tiny bit of Euler integration along that curve in the state space.
Okay, so from digging into the 6D Rubik's model, we're seeing this incredible interconnectedness, this hidden harmony governing it. Now, let's shift gears slightly to that second major area. How these ideas might unify with really fundamental challenges in number theory and algebra. The sources really spotlight the recent work of Norman Wildberger and Dean Rubin.
Yeah, this is fascinating. In early May 2025, apparently they published a paper introducing a new way to solve higher-order polynomial equations, finding the x in complicated equations. And their method uses power series and a new sequence they developed called the geode sequence, which itself is an extension of the well-known Catalan numbers from combinatorics.
And this work in algebra, which sounds separate, somehow connects back to the 6D harmonic stuff we've been discussing.
That's the proposal in the sources, yes. The connection point seems to be an instant prime factorization method that also uses a 6D harmonic framework along with logarithms and analyzing wave intersections.
Okay.
And the potential unifying idea, the bridge between number theory, primes, and algebra, polynomials, is something called the recursive base inversion principle.
Recursive base inversion principle.
Okay. Think of it as maybe a fundamental symmetry that underlies both how numbers are built from primes and how the solutions to equations are structured.
Interesting. Okay, let's try and unpack this proposed unified framework. Sounds like it has several moving parts working together.
It does, yeah. It starts with logarithmic prime detection. Basically, a quick way to check if a prime number p divides another number n. You just see if the logarithm of n using base p gives you a whole number, an integer.
Makes sense. If p is a factor, log base p of n should be an integer.
Exactly. And the sources stress this can be done easily in parallel, checking lots of potential prime factors simultaneously. Very efficient.
Okay. And then it brings in Pythagorean waves. That sounds cool.
It does, right. Using the basic trig identity, sin squared plus cos squared equals 1, they generate sine and cosine waves based on the logarithm of n to some chosen base. Then they look at where these waves cross and what their residues are.
Residues? Like leftovers?
Sort of, yeah. How much they deviate from 0 at key points. These residues give clues about n. A residue of 0 suggests primality or divisibility. A residue of 0.5 is linked to harmonic midpoints, maybe factors, and many 1 suggests some kind of phase opposition.
Wow, bringing wave properties into number theory. That's unexpected. And the framework also uses a ternary system.
Yes. For each number in being analyzed, they compute 3 key values, an average value, an arctangent, which gives a sort of phase angle indicating divisibility, perhaps, and those residues we just talked about.
Okay.
And these residues are thought to correspond to different harmonic roles and maybe even link up with those hyper-Catalan coefficients that Wildberger and Rubin use in their polynomial work.
Ah, a potential link.
Yeah.
And all this happens, again, within a 6D geometry. Same kind of conceptual space as a Rubik's model.
Seems so, yeah. A 6D space. 3 real dimensions, maybe representing start, middle, end aspects of a number sequence or polynomial structure, and 3 imaginary dimensions corresponding to those sine, cosine, and residue values.
Right.
The 6D space apparently defines 4 key points, but there's also a hidden 5th point where the real and imaginary aspects meet. And interestingly, the source notes these points can be viewed from 5, 3, and 2-point perspectives.
Which mirrors the structure of Wildberger and Rubin's geode sequence.
Exactly. Another potential connection point suggesting a shared underlying geometry.
So geometry underpins this approach to numbers and algebra, too. And then, maybe not surprisingly now, quaternions pop up again with quaternion torsion.
Yep, quaternions are back. Each of those points in the 6D space gets associated with a quaternion. Then they use cyclic shifts, like rotating the imaginary components of these quaternions to try and align those residue values.
Okay, why align the residues?
The idea proposed is that for prime numbers, after applying something called a doubling mechanism, this residue value neatly becomes 0.
And what does this doubling mechanism do?
Well, mathematically, doubling the number in that you're testing seems to get rid of those 0.5 residues, the halfway points. But crucially, it does this while preserving the logarithmic relationships needed for the prime detection part. The source suggests it's mathematically similar to doing a 180-degree rotation with a quaternion. Again, that rotational harmonic idea.
It really feels like there's a consistent mathematical language being used across these different areas: logs, waves, geometry, quaternions, rotations. And then we get to the recursive base inversion principle.
Right.
Highlighted as maybe the fundamental unifying symmetry.
Right. This principle basically says that x to the power of a in base b is equivalent to x to the power of negative a in the same base b, and that's also equivalent to x to the power of a, but in the reciprocal base 1 over b.
Whoa, okay, so xk base b equals x base 1b.
Exactly. It's presented as this fundamental duality: a symmetry connecting expansion, positive exponent, and compression, negative exponent, or reciprocal base. And this might be what governs the harmonic transitions within that 6D space for both numbers and polynomials.
A kind of mathematical mirror linking forwards and backwards, or expansion and contraction. And this is the proposed bridge between the prime method and Wildberger and Rubin's polynomial solution.
That seems to be the idea. Remember, their method uses power series and that geode sequence, counting ways to divide polygons.
Right, combinatoric.
That combinatorial structure seems to parallel the 6D model's point structure, and it's suggested that the hypercatalan numbers they use might feed into or be related to the residue calculations in the prime factorization method, creating that deeper link.
It's really fascinating seeing these threads potentially weave together. The sources also give credit to a specific group working on this unified framework.
Yes, they mention an independent group led by the author of the source material, including names like Jean-Charles Tesson, Ariader Slicer, Christian Barker, Kirby Cooper, and Richard Bolt. They're credited with developing this integrated approach, apparently building on earlier work in recursive harmonic systems. And Ariader Slicer specifically is mentioned as having a YouTube channel focused on harmonic frequencies, sort of laying some of the groundwork.
And to make it less abstract, the sources even include a Python script as a demo.
Yeah, which is great. It apparently shows the prime factorization for the number 17, confirming it's prime using this method. And it also tackles a quintic polynomial by 5 by 1 equals 0, giving an approximate root.
Seeing actual code running it definitely makes it feel more, well, real.
Absolutely. More concrete.
So, okay, if this unified framework pans out, what are the potential real-world applications? Where could this lead?
Well, the implications could be pretty significant, potentially across several fields. Cryptography is the obvious one.
Right, breaking RSA.
If you have truly fast prime factorization, yeah, that could challenge systems like RSA that rely on factorization being hard. Then in physics, maybe these harmonic models could align with quantum wave functions, or the geode's geometry might offer insights into gravity theories. It's speculative, but interesting.
And AI.
And in AI, the fact that these algorithms seem parallelizable, you can run parts of them simultaneously that could lead to faster, more optimized machine learning.
That's a really broad spectrum of possibilities. The sources also use some interesting analogies to help, wrap our heads around it all, like this DMT and red light analogy.
Yeah, that one's quite evocative. The idea is that primes or polynomial roots are like these hidden patterns all around us, and this new mathematical framework is like tuning into a specific frequency. Like red light is just one frequency of electromagnetism.
Oh, okay.
The DMT part suggests it's like a perceptual shift, allowing us to suddenly see this underlying 6D structure that was maybe there all along, but invisible to our old mathematical eyes. It's trying to make the abstract feel more intuitive.
A mathematical mind expander, perhaps?
Yeah.
And finally, there's even a viral strategy mentioned for getting these ideas out there.
Yeah, the sources outline a plan. Using social media, visuals, maybe even memes, community challenges. The goal seems to be generating broad interest, sparking discussion, getting more eyes on these ideas both inside and outside the traditional math community.
It's really quite something to think about how exploring something as abstract as a recursive harmonic Rubik's framework could potentially unlock these deep interconnected patterns running through mathematics. It's genuinely surprising to see these potential links pop up between, the hidden symmetries of a theoretical 6D cube and these really old fundamental problems like understanding primes or solving tricky equations, problems mathematicians have wrestled with for centuries.
And what keeps striking me is this recurring theme, this concept of harmonic resonance. It feels like it's popping up everywhere in this framework.
It really does.
It makes you wonder, could that be a fundamental key, a principle for unlocking more secrets? Maybe not just in math, but in other areas of science, too.
It absolutely makes you think, doesn't it?
Yeah.
I mean, for you listening, how might this idea have hidden patterns, unifying principles, harmonic resonance, how might that apply in your own field, your own area of interest or study? Could there be some underlying harmony, some resonance waiting to be found that could totally reshape how we understand problems that seem intractable right now?
It's a provocative thought. And for those of you who found this deep dive really piqued your interest, maybe a next step could be looking into the work of Norman Wildberger and Dean Rubin directly, or exploring concepts like quaternions or harmonic analysis in a bit more detail.
Absolutely. Well, thanks for joining us for this deep dive into some truly mind-bending ideas today.
It's been fascinating.
Until our next exploration, keep questioning, keep looking for those hidden patterns all around you.